Hi guys, welcome to the channel. I am Gourav Nayyar and today I am going to walk you through the Liskov substitution principle. From the solid acronym, this is the principle which starts with L. We would be covering today definition of Liskov. We'll try to understand the problem in the design we face with an example, and what we will do in the end, we'll try to refactor that code. So let's try to understand the definition. This definition I've got it from Wikipedia. This says the substitutability is a principle in which in the object-oriented programming stating that in a computer program, if S is a subtype of T, then object of T may be replaced with object of type S. It might not be very clear with the definition, but the pointer we are going to take from this slide is when we talk about S is a subtype of T, we are talking about inheritance. And what we are trying to do here is we are trying to substitute the base class object with the subclass object. And this is another definition which is from the book Agile Principle Patterns and Practices, and it states that if we are talking about S is a subtype of T, replace the object of T with S and it should not create any problem. I'll show you an example how this example code will break the Liskov substitution principle, and this principle was given by Barbara Liskov, who first described the principle in 1988. This is a very good example which I've got it from Google, which shows two ducks. So you have a parent and then you have a subclass. The subclass one, in this case, to operate the subclass we need batteries. So let's read out what this example says. The second duck, it looks like a duck, quacks like a duck, but needs batteries. You probably have the wrong abstraction. So in this case, if you replace the main duck object with the battery duck object, what it is going to do, it is going to break the functionality of the parent class. So this is the first part of the definition which I wanted to make clear with this example. So let's understand the basic rules. It says the child class must not remove the base class behavior, violates base class invariance. And the second part which I wanted to highlight is calling code must not require to know that they are different from their base type. So let's go back to the example where we discussed about the duck. So if you have a good type of abstraction, your calling code should just call the object and that should be taken care by your abstraction. Inheritance and the is a relationship. So OOPS teaches use of is a to describe the child class relationship to the base class. Clear enough? What LSP suggests that is a should be replaced with is substitutable for. So you can substitute your base class object or the base class object with the subclass object. So let's understand the Liskov with the help of a demo. So whatever we have discussed until now, I'm going to explain in a demo as well. I'm going to take an example of a rectangle and we are going to calculate the area. Just copy and paste. So what we are doing here is I have a class rectangle width and length which is initialized to 0, 0, and then I have a variable which calculates the area. We can have a method also which calculates the area, and area is returning width into length. Okay, and later what the requirement is, like I wanted to calculate the area of a square. Okay, so what for that case I will do is I'll take a class, I'll inherit it from rectangle, and then what I will do here, now my parent class has two properties. So I can say if the width is if somebody is trying to set a width, I'll calculate the length on its own. Okay, so what I did is I created a class square which is a subclass of rectangle, and here I'm overriding a property of width. I have a method called print area which takes an object of rectangle and then calculates the area. Simple enough. So what we are doing is, I have a rectangle class, I have a square class which is a subclass of rectangle. Rectangle is the superclass here, and then I have a method called print area which calls rectangle dot area. Correct? Now let's take an example where from the client end I will do this. So where I'm creating an object of the rectangle class, I'm setting length, width, I'm trying to calculate the area. So let's see what I get. So I get 6, which is clean enough. And now let's create a square, and here I set the side equal to width equal to 5, and I get the area. Now we wanted to see where exactly the problem is. So as Liskov substitution method says, when you substitute a object of the base class, it should not create a problem. So I'm gonna show you now how we can actually see this violating Liskov substitution. So I'll create a rect2, which I'll type inference with rectangle, and I'll say but it is a type of square. That I can do because since it's a parent class, I can set it as a this. Now when I say my rect2 dot length is equal to 4 and rect2 dot width equal to 5, and now I'll call rect2 dot area, or I'll calculate the print area. Okay, now in this case eventually the expectation was 4 into 5, which has to be 20. So the rect I wanted to calculate, which is 4 into 5. Now you could see this is breaking the Liskov substitution principle. Delete whatever we have done till now. Let's start from the fresh. What I wanted to do is, I need to create a protocol. Say like I have a protocol called shape, because tomorrow if you add something else like in a triangle, so the way we calculate area for triangle might be different. So you set a rule which will not let your base class to break subclass to break any principle in your base class. Okay, so now in the similar way I'll have a rectangle class. Okay, and now what we are doing here is that is conforming to our protocol shape. So when you conform to a protocol, you need to implement the method. So the method says the area should be width into length. But now in case of square, this should also, now my class square should also conform to protocol shape. Now for square, what I need is side. So area, how I'll calculate? In side into side, because the sides are equal in this case. So now the way I will be calculating is this. And now in this case, your since we break the concept of inheritance, we don't fall into the Liskov substitution. So this is one way of solving this. So this is it for today's class. Please do let me know in the comment section if you have any questions, and I'll see you in my next class. Thank you.